So here we have one more case here. What is that? So you know that what is that? The formula is there. N is equal to 1 by sin C, or C is equal to what? Sine inverse of 1 by n. He gave the, I think, refractive index 4 by 3. So we have to find out what is that. So what is that? C is equal to, this angle is C. This angle is nothing but C, which is theta. C is equal to sine inverse of 1 by 4 by 3. So implies it will become C is equal to sine inverse of 3 by 4. So 3 by 4 is how much? 0.75. So C is equal to sine inverse of 0.75. So sine inverse of 0.75 is approximately, like, because it is sine 90 will become 1. So is sine 45 is how much? Sine 45 value 1 by root 2, right? 0.707. See, sine 45 value is 0.707. It is very close to that. So when they calculated, you have to use the log table to calculate this. So it is how much? 48.7 degrees. So it is 2c, theta and theta. So that will become 2c, which is equal to how much? 97.4. Is that clear? 97.4%. Is it clear now?
Yes.
So there is one more numerical of the same category. We'll do that also. This came in the board exam again. Now, so he says that a point source of light S is placed at the bottom of the vessel containing a liquid of refractive index pi by 3. Okay. A person is viewing the source from above the surface. So what happened here? So this is the liquid now from the bottom of the surface. There is an object. Now, whose refractive index how much? 5 by 3. Means n is equal to 5 by 3. And this is air, n is equal to 1. Now, a person is viewing the source from above the surface. There is an opaque disc of radius 1 centimeter floating on the surface. Okay, so like there is a disc here. We can think like this is a disc type. Okay, so this is a disc now, opaque disc. So the center of disc lies vertically above the source here. The center is exactly lying. This center of this is lying exactly on the above the object form. Now above the object, the liquid from the vessel is gradually drained out from a tap. What is the maximum height of the liquid for which the source cannot be seen at all? Now, see here, we have to find out, this is the height. We have to find out what is the height of the water. And this is the critical angle. This angle and this angle will be same. Alternate angles will be equal. And this will be 90 degrees. Again, we have to use, once again, there is a source and there is water. This whole thing is water. At the bottom of the water, there is an object, and we have kept a disc over there. Okay, the disc is there, and what happens? Light will there. The critical angle is taking place. Refractive index is 5 by 3 here, and this is 1. We have to find out what is the height. Okay, now, so here what happens here? C is the critical angle, H is the height. So we have OSA. Whatever the triangle you have a right angle triangle. So you'll find out sine C. Okay. So sine C is equal to what? Opposite side divided by hypotenuse. Okay. So sine C is equal to what? Opposite side is the radius R, and this will become how much? This value will become H square plus R square. Okay. H square plus R square. Sine C will be equal to R divided by under root of H square by R square. So now, that is also equal to what? Refractive index. So sine C is equal to mu is equal to 1 by sine C, right? So we have the formula mu is equal to 1 by sine C. So if you cross multiply, this will become 1 by mu. Okay, we got the value as 1 by mu. Now cross multiply this, square it and cross multiply and simplify this one. We'll get the answer. I'm taking this one here. So r square divided by h square plus r square is equal to 1 by mu square. Okay. 1 by mu square. Now cross multiply this. When you cross multiply, r square into mu square is equal to h square plus r square. So we will take r square common. So what will happen now? R square mu square minus r square is equal to h square. R square you take common, mu square minus 1 is equal to h square. Okay, equal to what? H square. So h is equal to how much? Under root of, we get that value. So h is equal to r into under root of mu square minus 1. R into mu square minus 1, which is also equal to, when you substitute these values, what happens now? H is equal to what? H is equal to r value is 1 centimeter under root of 5 by 3 whole square, 25 by 3 minus 1. Simplify, h is equal to how much? 25 minus 9 becomes 16 by 3. So that is equal to what? 4 by root 3. This is the height of the, okay. Is that clear? 4 by 3 is 9 now. This will become 9 and this will become 9 and this will become 3. 4 by 3. The height of this water level is 5 by 3. Once again I will explain. There is a water and there is a object here at the bottom. Now here there is a disc on the surface of the water, and what happens when the light incidents on this? There is a critical angle at that point. Now, and the refractive index of this water is given to you, and this is n is equal to 1. So use the formula sin theta is equal to, if this is h and this is r, this automatically will become h square plus r square. So sin c is equal to r by under root of h square by r square, 1 by mu. So cross multiply mu is equal to 1 by c, r square by h square plus r square is 1 by mu square. Cross multiply this and simplify this one. You'll get h value. Then h is equal to under root of 16 by 9.
Minus 1.
Where? Here?
Mu square minus 1.
Here? Yeah, mu square minus 1. We took r square common, right? Is it clear, all of you? There is one more question of the same type. I will try that also with you people. So this type of question they are asking for 2 marker in the exam. One more question is that I will try with you. Here there is one more question. The critical angle. So the critical angle of incidence of incidence. Critical angle of incidence. Okay, ठीक है. क्या हो?
So she is problem breathing.
So the critical angle of incidence in a glass slab. Incidence of a glass slab is 45 degrees. Is 45 degrees. What will be the critical angle? What will be the critical angle when the glass slab is immersed? When the glass slab is immersed. When the glass slab is immersed in water of refractive index. In water of refractive index 1.33. Now, what is the formula here? Mu is equal to what? Mu is equal to 1 by sin c. This is the formula for is equal to what? This is first we are calculating in air, glass slab in air. So what is that value? That will be 1 by root 2. 1 by root 2, that will become root 2, which is 1.414. This is the critical angle when the glass slab is in the air. Means what? And this is the ray. Now what happened? This is what he's speaking about. This critical angle he's speaking about. Okay. The first part. Second part is here. What will be the critical angle when the glass slab is immersed in water? Now we are going to immerse the same thing. Now this is the water. So we have water now. In that we have immersed because this is denser medium. This glass is a denser medium. Water is a rarer medium now because the glass has 1.5 and this is 1.3. So he's asking what will be the critical angle now here in this case. Okay. So we have the formula, right? So refractive index of So this you can use a simple formula. What is it? So now here we have refractive index of glass by refractive index of water is equal to 1.414 divided by 1.33. So then what we have here? So we get this value that is known as refractive index of glass with respect to water. Refractive index of glass with respect to water. Refractive index of glass with respect to water. We can write anyway. Now what is sin C? Mu is equal to 1 by sin C. Okay. Or we can sin C. We can also write C is equal to sin inverse of 1 by mu. Okay, sin inverse of 1 by mu. So we're going to substitute all these values in the in that formula. So what do we get now? Sin C is equal to what? Sin inverse of 1 by mu. 1 by mu is how much? 1.414 divided by 1.33. So I get C is equal to sin inverse of 1.33 divided by 1.414. Okay, 1.414. So that will become equal to what? C is equal to what? Sin inverse of 0.994. Okay, so that is C is equal to what? Answer is 70 degrees, 36 minutes, something like this. Okay, so is it clear now? First, what happened? We are taking glass and air. We found out the refractive index. Then second time the same glass is immersed in the water. What is the critical angle? We found out in this way. Clear? What are the two conditions for critical angle? The TIR, number one, the light has to travel from denser to rarer medium.
Denser to rarer.
Second is angle of incidence should be greater than the critical angle. Okay, so these are the two situations. So we have taken refractive index for glass with respect to the water. We got this value. Now the refractive index formula, the critical angle formula is mu is equal to 1 by sin C or C is equal to sin inverse of 1 by mu. Now substitute all the values in that formula, we'll get the answer. Clear?
Yes, sir.
Yeah.